Okay, oops, I want to do that. I think I should be live. So today we're going to be working on something a little different. So yeah, I'm going to be programming a little bit. I'm going to do a bit of graphics program today, and actually I should probably remember to quickly update my stream tags. I'll just add some practical and OpenGL and graphics. Okay, so we are going to be making, or at least starting to make, a Mandelbrot set viewer. So if people don't know what the Mandelbrot set is, I will drag over this window from Wikipedia here. So it's basically just a fractal. It's defined by like this very simple equation, z squared plus c, where both z and c are complex numbers. And you can zoom on different, like depending on the value of c and depending on where you zoom in, you're going to zoom in and see all sorts of different patterns, and they're just going to be infinitely repeating. But never, or sorry, they're going to be, they don't repeat. So I guess like a fractal is just a infinitely complex pattern that never repeats. There's going to be like a few interesting challenges that are going to come from this, but we will see about those when we get to them. Now, first thing that we need to do is obviously we're going to be using OpenGL. Now, I haven't used Raylib before, so I'm thinking I'm going to use Raylib for this project. Oops, what am I doing? We're going to move so raylib.h into this folder. So now raylib.h is one of those fancy single header C libraries. It's just going to define some functions and some helpful things for basically drawing various shapes and other stuff. So I'm going to have, I'm looking off the other screen, it's because I'm going to be looking at the FAQ to see how they suggest you use it. Also, I might bring up, they have a sample program, if I'm not mistaken. Now, all I really care about right now is opening a window. So how did they do that? This one here. If I'm not mistaken, I was under the impression that to use this, you're supposed to define like Raylib definition or something. Implementation. I could be wrong about that. So, oops, didn't want to do that. So, bring this over. Therefore, what do we need to do? Possibly we just need to, I don't want to paste whatever that was. Possibly we just need to include it. Not really seeing why we couldn't just include this directly. This file's like 7,000 lines long, so obviously I'm not going to go through all of it, but to me it looks like It's rline, it's RL API macro. Probably going to tell us what we need to do here. Oops. It's actually not 7,000 lines long, never mind. As it's even the, I think maybe I'm missing part of it then. That might be the problem. I think the header should be a source file as well, not just the header. So raylib.c possibly. Okay, here we go. This basic window example. So this one just talks about the header stuff. So we need the actual code. So I'm just going to be let's have a look. I'll download this tarball and we will extract it and see what's inside. So we'll just unpack raylib to T and we'll have a look here. They have some libs here that they want you to link against and include. So I will probably, in that case, I will just copy, move the raylib.a out of this folder, and we will be statically linking that one. And then RLGL. Probably I need this. Choosing OpenGL backend. We look at the example program. One might give us some hints here. Now, where is that one? They have like this giant complicated makefile and a bunch of stuff that I don't really care about. So I would prefer to just load the simple, just do exactly what they did in the simple example, but raylib examples, basic window, source code. All this shows is the how to open a window. It doesn't actually show how they built this function, how they built this program. So well, I think we'll just start building. I'll copy that and I'll use the header, and we will go from there. So let's get out of here. Let's remove the raylib header. Let's move the T, include raylib.h here. And then we will open a new main.c and we will include raylib.h. we'll do a new main. Now we'll take no arguments, and we will, and the window size doesn't really matter that much for what I'm doing here because I'm using a tiling window manager, so it's just gonna get reset immediately, resized immediately, but we will just copy paste, this. So screen width, we will just do, to begin with, we'll just do a 720p window, but we'll change this later on. For the window name, we will use Mandelbrot viewer, and so they have a main function here, so you can only have one window open at a time, I guess. Maybe there's a way of doing sub windows, but we will see for now. And you do begin drawing. I guess we should look up some of these functions here. Clear background, and then you can draw some text. Actually, sure. Hello world. 1900. We'll have to look up the documentation for this in a second here. And turn 0. So that is all we need here. Now I'll just open a quick build.sh script, and we will do set. First, we'll just do a crunch bang bin/sh. Set x for trace, and then if that for now, we'll just do mmark equals native and -o 3 because we like to be fast, I guess. main.c-o Mandelbrot. Close both of those, and then we will build.sh and do a build.sh. Now we need to add some stuff to build.sh, so obviously we could do raylib. Now maybe is not going to like me. Let's actually just copy this for now. So raylib .a, it was libraylib.a. Probably I can just manually link this. So we will just do this. And then we will do an ld main.c ld main.c libraylib.a. And I guess I need to do an O. Let's try this. How do we use LLD again? Okay. So this is a little annoying. That's okay. So usually it is options file output is -o. So it should just be ld main.o libraylib.a -o. Okay. So we need lm. seek this maybe is too much effort. I should just use the dynamic library, but this isn't going to run on my system. So actually, well, neither is the raylib database. So that's actually the problem. The problem is that raylib is going to be compiled for glibc, not muscle. Now, the static one could potentially work, but just see if there is a better way of doing this. It doesn't involve me. Probably I can just build raylib myself. Well, it actually looks like raylib is in the guru repository for Gen2. So I will just install it this way for now, but I'm gonna fix this later. So this should all be okay. So we will take a second here to just build that. It shouldn't take too long, and then let us. Okay, so is there package config file for raylib? Probably I can just do the lraylib. There we go. So we've got an output binary now, and we've got a window. Now actually this window's floating by default, which is interesting. I was not expecting that. And we've got our hello world. Cool, so there shouldn't be anything else we need to worry about there. We will close it. And I will need to bring up the cheat sheet. So the one problem here is that I wanted to do this stuff using a shader. So all the Mandelbrot stuff will be calculated in like a GPU shader. Now, not sure if or how raylib lets us do that. So basically, I just want to draw a single rectangle to the screen, and then in the fragment shader, I will go and do all the Mandelbrot drawing stuff. So that one, we might have to do something. So we can load shader. We can do stuff like, yeah, so we can load the shader. We can set a shader texture. Set shader uniform value for texture. Sampler 2D. Well, we're not going to be doing that. We're going to just we want to do here is we just want to load the shader from well, first I think what I should do is write my oh, so actually it looks like Actually, okay, this actually looks like it's a little easier. So their load shader function will load, just takes two file names and loads the shader. I don't need to really write any helper code for doing that. Now, that is fine. But what I need to figure out is how I can so clear background, that's fine. Begin drawing, end drawing. Begin 2D mode with a custom camera and 2D mode. I don't really care about that. So I want to render texture 2D target. I don't really want to do a lot of these things. I want to just I would like to just draw a static quad that just gets updated on every loop. Have a look at what this render texture. These are for texture loading. I don't really want to load any texture. I am just going to, we're not going to be updating or loading or doing any of that. Texture drawing functions. Draw texture 2D. I don't really want to do any of this. For what I'm doing, it might just be easier for me to just use lib glfw directly. Because Raylib looks like it's really nice if you want to be doing stuff like drawing shapes and, laying out like window stuff and blah, blah, blah. But it may be a little complicated for me to just start drawing stuff with the shader. Let me see though. Is there a way to just so you can set shader value is shader ready? Get shader location. That will tell you that. That will get you shader attribute names. Well, I'll just continue with this for now, so that is okay. Now, actually, I want to see quickly, though, what is a color, so I can just draw some nicer, clear color that's not white. So it seems like a color is a 4-component vector, RGBA, and so ray white is just a yeah, so this should be fine. So let us just do a color, clear color, and it is going to be equal to just some nice light gray. So let's do 64, 64, oops, 64, 255 for the alpha. Just do clear color and Mandelbrot. Oops. There's our gray with our hello world text still. I would like for this to not just be a floating window, to be honest, because it would help me a little bit with what I'm trying to show here, but let's see. Window, how do we just... We can try to toggle borderless windowed mode. That might do it. Do this. It's up a little bit. I'll do it here and see what happens. So that is not what I want to happen. Do not want it to take over the full screen. Huh. I don't know how I can just get it to properly draw itself so that it's not floating. Actually, I don't even know why it's floating, to be honest, because it shouldn't be like a window type that's set to float. So huh. Okay, so let us... What should we do? What should we do here? Now, so let us see. Whole input, wait time, get random values. Huh. I mean, I guess I could bring this up on the main monitor here so we can see what I'm looking at. Maybe a little bit better stream value. I did that. So what do we got here? Just move this window to where I can see it. So what do we have? We have all these window functions, but none of them seem to do what I would like to do. Flag window resizable. Init window width, height, that. So how can we set it to be resizable? That is what I want. Resizable. Oh, not that one. Is window resized? Huh. So how do you set window state possibly, and then there will be a window state flag that is probably for resizable. Set window state. Flags. Flags. Huh. So probably flag window resizable is what we need. And we will just try doing this again. Okay, so that is what I want. and I don't want this toggle border list thing, and I would like for it to start in the frame like that, but anyways, that is okay. Let us get rid of this cheat sheet for now. So let's do it this way. So with this, we have our nice window. And what we are going to want to do is figure out how to get single quad on the screen. So this is the background. So this is like the GL clear. But what we want to do is have a single quad that takes up the whole window, and then, oops, that button. And then once we have that, we can set the fragment shader up to just do all the coloring. So get window position, window scale, window height. So load shader, we don't care about load shader. I guess I should leave this over here for what I'm doing. So we will care about load shader in a second here, but we need to be able to first draw just a simple vector or simple quad. So like draw a rectangle, we'll draw a color-filled rectangle. So these are all color-filled. I don't want that. I actually don't want any of these at all. So these are all gonna like fill the color or do something. We don't actually want any of that. I just want to set so our textures. Let's see here. Yeah, we're not going to be doing any of this or setting any of these either. This is how we could get some colors. I don't really care about that. I don't care about the text right now. So can we just do this here? Here's like some drawing in 3D. Draw a plane, draw a ray. None of this is really what we want. Though this could be useful if you want to do like some drawing. But really all I want is to it's not really a mesh. Upload mesh vertex data in GPU and provide VBO, VBO. So maybe I just need a mesh. This is expecting it to be in a certain format that I'm not really interested in. So let us see. We don't need to see those chat settings. This is again just checking all these input. I don't really care about any of this. You can start setting up a canvas to start drawing, but all I want to do is draw a simple quad. So what I might do is just switch to GLFW because that will give me a little bit more raw access to the OpenGL stuff, which is what I want for what I'm doing right here. Don't want this. I just want I just want a literal huh. Okay, so maybe this is not what I'm gonna use. Maybe we are going to not use that. And we will just use GLFW, which I'm used to using. So do that though. We're gonna have to write some more code and also like a lot of boilerplate, but that's okay. So we're gonna drop this, delete all that for now. We are going to include, to begin with, what is the header even called? Hello, Fern of Sigma. I'm good. How about yourself? I'm going to be working on like a Mandelbrot viewer. Now, I was thinking about just using, did crop that. I was thinking about just using Raylib. Now, unfortunately, it seems like Raylib makes it a little difficult if all you want to do is put 4 vertices on. It'll be in C. It'll all be in C. Yeah. The Raylib's also in C, but here we go. Let's just crop this new line. Out of there, because that doesn't matter. Bug report, Augment, Debian, L. I'm not sure what this is. I don't use Debian, so I don't really I don't really have any comments on Debian right now to begin with. But what we want to do here is include no, actually this, let me just hide this for a second here so we can, don't want these alternating lines, which is more of a Franker face Z thing if I'm not mistaken. Alternate chat lines. No, we don't want that. Yeah, that's better. Is that better? That's much worse. Why did that happen? Interesting. Well, weird. Why did it decide to chroma key out the text this time? With the key password management features. So they set up the build. I mean, I don't know. I don't really use that password manager either, so I'm not too sure. I would like for this to be rendering properly though, which would be nice. I think for now, until I figure this out, I'll just turn this off so that we can see it properly. Okay. So include glfw slash glfw.h. So I don't actually use it. I use just GPG encrypted files for my password manager, and then I use I'm not going to insert any passwords, but like I have a dmenu script for auto typing them into whatever window I currently have focused. I think that should be correct. And then we also need is I'm gonna have to look at some of my example code for this one, or not my example code, but like a different project. So I can remind myself how to do this. Usually you don't end up opening windows over and over again, so it's hard to remember how to open a window. It's like a thing you set up once and then you forget. So we are going to store a, we'll have to store it somewhere else for now, but for now I will just, I also did this wrong up here, so it should be gl/gl.h glfw3. I'm gonna just store a global window pointer, and we will start by doing. So I did like a lot of cleanup, and I opened like a pull request to see if anyone had any comments. There's some other work that could be done, of course, but thought it'd be more interesting to work on something a little different this time around. So glfw, usually I'd like to maybe just have like a spawn window function. So it will return the glfw window pointer for now. Spawn window, and usually I don't pass it any variables. So we are going to open a monitor here, get the primary monitor. If I think you have to call glfw init before you do any of this. So we will do that from main. So if this not, we will just return -1 for now. We might do this in a different place later. This is going to be window, and I should probably call this something so we know it's a global variable. Call it g window, and we'll do spawn window. And then while not glfw window should close window. Of our main loop. Usually we need to have some sort of poll. Should finish writing the window function maybe before I start writing all of this stuff. So window function. If not monitor, so if the monitor is null, we need to for now I'm going to return -1 or null, and we will probably clean this up after, but for now this is fine. So if g window equals null, we're going to return -1. Now technically I should probably call some stuff like glfw terminate. Don't know if I care that much. Probably I don't really know. If it cleans up GPU resources, it might be smart to do such a thing. So but I'll do that in main. if we need to just exit early. So that, and then next, next we want to get some, usually I like to have this stored, like the window width and height will be constantly stored somewhere. So already I probably want to make this into like a struct. So we will have a struct here that's going to be GL, sure, GL context. So we will have our window pointer, and then we will have a couple of integers. Now, usually when I'm coding, I don't like to have C-style integers everywhere. I like to have fixed width integers. So we will include standard int.h, and we will start type defing some types that I like to use. So type def int 32 e to I32. That's all I need right now, but while I'm here, do this. U32, float, F32. Probably I'm not going to be using any doubles, so we'll just leave it with that for now. Usually I want a uint 8, a u8 for any binary data, or any like so any like raw data, point strings, whatever. So far we don't have any need for strings, so I'll leave the strings out. But we will start by adding we will add a int for height and an int for width. And then what we can do is do a glfw get monitor work area. So this will basically just determine the total width of the monitor, total width and height of the monitor in pixels, which is fine because we're going to use that for determining the size of the texture that we will render. Then after we're done with that, we want to do some more boilerplate, which is setting up the window hints for GLFW. So yeah, we will just stick with OpenGL 4.6. There's not really, I don't really see a reason not to use that right now. Even though we probably won't necessarily be using any functions that are limited to that. Forward compat, this I'm not sure really matters, to be honest. I'm gonna delete that for now. And then for the OpenGL core file, we want the fast core profile. We don't want the basic whatever profile. So once we've done that, now maybe what we could do is, I don't really want to do that. So well, the way this is going now is we can just assign the window in here and then do if GL context dot window is null, we will do that. So now we can spawn the actual window. So that is just going to be a GL context dot window is equal to GLFW create window. One thing I did not check here. Okay, so GLFW create window with the width and height that we just calculated or that we just got. These are just going to get resized, but that's fine. And then the window name. So again, Mandelbrot viewer. Let's just break this up. And then, really I should see if I have the, oops. I don't have the GLFW man pages installed, which is a little annoying. But what we can do is do a GLFW create window, get the window reference, and it will tell us that so the last parameter is, the second last parameter is the monitor. Really, we don't need to specify this because the primary monitor would be default, but since we just have it, we'll just do that. And then this last parameter is whether or not the window should be shared. Which I'm not actually sure. I think that's if you spawn like, that's, you usually want to, I think you want to use that if you're going to spawn extra windows, but we are not going to be spawning any extra windows, so I don't need to worry about that. So there's that. Next we want to do our little check here. Really, we can make this return an int. But yeah, we had to fix this, so we will return -1. If this thing is null, we will also return -1. Now there's one thing I didn't actually remember to check, so I don't remember if you're supposed to do anything with this GLFW monitor pointer after you get it. I don't think you are, to be honest, but I'll have a look quickly. GLFW primary monitor. Yeah, it doesn't say anything about freeing that pointer or doing anything with that pointer, so I will just leave it to just get stack deallocated. Now, next we need to make the window context current. So we have a window, we need to make it current. Screw this up. And then, you're going to want to set a couple callbacks as well. So the frame buffer callback we're going to want to set. So the frame buffer callback gets called when the when the window gets resized. So we will define that up here. Now the frame buffer callback takes some parameters. Just do this. So it returns nothing. It will take the window, and then these can be I32, I32. So these are the new sizes for the window. So now what we will do here is we will set GL context dot height to the new height and GL context width to the new width. And then so I thought that you should set the viewport. Yeah, so you want to set the viewport. So now when we just get this new size, we're going to set the viewport. So the viewport, we already have like a valid OpenGL context, so we can just call the GL viewport directly. It takes an offset from the corner, and it takes the width and height. Now, we might come back later here. You can use this to actually add like some padding around the window so it doesn't draw right up to the edge. We will see if I want to bother with that or not. But for now, this should be fine. You don't really need to do anything else with this new width and height, so we're not going to be we're not going to need to do anything with like converting screen coordinates to GL coordinates or back and forth, because we're just going to set like one set of vertices at the start of the program and then just use the fragment shader to just draw Mandelbrot stuff. So that is all we need to do there. So that now has this callback set. So that is good for that. Now the refresh callback. The refresh callback gets called when your window should redraw, as if something like has gone over the window or something like that. Probably for now, we will not set that because I don't think it is going to be that relevant for this program. But what else do we need to do? So other things like scroll and key callback, I will just put some comments here. So we're probably going to want to handle keys and mouse scrolling, and then also the mouse callback at some point, but I'm already calling this the wrong thing because this was from another code. We probably also want to set the viewport here, so... Well, no, never mind. We don't care. The viewport's just going to be like the full width and height, so we don't need to set it here. If you wanted to just draw like a square window, a square viewport, you could do that. Even if your monitor was 16 by 9. So the next thing to do is just clear the color so that it is not black. So what we probably want to do is well, probably we want a color type. So I will do that. Now there's some fun stuff you can just do with unions and C11. So we are going to do this fun thing where we will use an anonymous union to define our color. And it's going to be color. So we're going to do a struct of U8s. So it will just be a packed integer color. It'll be RGB and A. And then we will have this anonymous structure, and it is going to be in union with the U32 that will be a B. So this is actually opposite. So actually, I want to do, I want the U32 to be RGBA. So I actually have to flip this around. So because this is just running on a little endian machine, the least significant bit, which I want it to be A, is stored first in memory. So we have to flip our struct around here so that we get RGBA as this when we access it using this member. But then if you want to access individual elements, it doesn't matter. You can still just well, I'll just display how we're going to do this. So let us, with that color, let us set like this can also be a static. Everything's going to be static, as you'll see soon. But so static. Maybe we want to just store that in here. Sure, let us store it in here. So color, clear color, is going to be equal to a color. We don't need to do that. Is going to be equal to a dot R. For now, it's just going to be the same thing we had before. So 64, 64A is equal to 255. So that is that. And we will do a the GL clear color is a little annoying, so but oh well. So I'm gonna actually make this a function so that I don't have to keep doing this over and over again every time I want to clear the screen. Static void clear color. I'm gonna take a color C, and it is going to call GL clear color, but with, there might be a better way of doing this, but we will just do it this way for now. Over 255 F, and then RG C dot G over 255 F and C dot A over 255 F. So that will clear the screen, and then you have to call GL, or that will set the clear color, I should say. And then you have to call GL clear GL color buffer bit. So we will do that. We will do down here, now that we have a window thing, we will do clear color, GL context, GL context dot clear color. And that will be it for this function. So we will return a 0. Oops. That is that. Now with that, we can probably just do our, well, I don't really need to clear it here, but clear it, sorry, up in the spawn window, but we're just gonna do it in this main loop for now, but that's okay. So if we do this, and we do, next we have to do some what's it called? Like, I don't think it's anything else. I think we just have to do this. So, and then we can just call GLFW poll events to make sure that we handle or we get any events that happen. So now if we go ahead and open our build script, not doing this one anymore, we're gonna do gonna make a C flags variable. Oops. And that's gonna be equal to package config C flags glfw gl and then LD flags, same thing, except this should be LD flags. Flags. We go, and then what we'll do is we will do C flags. Let's actually set all the C flags. So C flags is equal to mark native 03. And this is updated C flags, which will be C flags. C flags and that. And then this LD flags is fine. And then here, do C flags and LD flags at the end. Now we can do a build. Some errors because I'm bad at programming. I have skill issues, as my tags say. That seems wrong. Oh, oops. Can't do this. This is C. This is C. You cannot do that. So when we're just spawning the window, we will set that. After we're done spawning the window, I guess before we call this. GGL context. Clear color is equal to color. Dash R equals 64. Dash B equals 64. Dash G equals 64. Dash dot A equals 255. Sure. That should be better. And then this is GL context window. Happened there. RDG, doesn't matter. What is this complaining about? Field designator null does not refer to oh, thank you. I don't know what that part's about, but be this, and then okay, so well, oops, I actually know why that is. This is not GLFW, it's GLFW3. And then let me just check. Oh, it's mouse is libs. um, so I doing something. Oh, I think that if you are doing this, this has to go before you do. What am I doing wrong today? Not native O3, C flags. Well, that would probably be the problem, wouldn't it? Good. Good naming skills. So now we should probably get a window that is not refreshing. Weird. So it should be coloring the window every time we're... Am I like forgetting a full... Oh yeah, duh. So yeah, we need to swap buffers. So close that. Yeah, there we go. So now we have a blank window with the we got a blank window and the title is set properly. Mandelbrot viewer. So that is good. We are starting to get somewhere. One thing we probably want to do is handle some keys such as escape so that we can close this without doing that. So maybe I will just do that quickly. We won't add any other keys. We'll just add that key so that we can close the window without killing the process. So copy this. I don't know why I'm copying that because it takes completely different arguments, but that is fine. The key callback is going to take key, I32 scan code, an action for the key, and a modifier. And all we really need here is we don't need the scan code, and we don't need the modifier right now. So I will just do this so that the compiler, well, I enable warnings, which I should do right now. So wall error. So we'll do that so that the compiler doesn't complain to me about not using those variables. And then we will do if p equals glfw p escape and action equals glfw press. We will do glfw set window should close. This will exit the loop after the next iteration. after the key is pressed. So we want to do GL context window, or we have the window and GL true. And that should be it for that one. So let's just. Okay, so then if we press escape, it closes the window and exits. That is good. As you can already see, like there's a lot of just random boilerplate that Raylib covers up. Fortunately, sometimes you have to deal with the boilerplate. I'm omitting like much of the boilerplate by using GLFW instead of just opening a raw X11 window. If I was doing that, there would be significantly more boilerplate. So for now, this is fine. So I don't know why I called this an int mod instead of I32 mod, but that is fine. Next, what we were going to want to do is probably, yeah, we're going to have to set up like a, we're going to have to do the fun, setting up of a vertex, like set up a vertex buffer, vertex array object, etc., etc. So, how did I do this before? Let's see. So yeah, this is let us do a struct let's not do a struct. Actually, I've changed my mind. We will store I believe all I need to store is the vertex array object and the vertex buffer object. I don't need to use an index buffer because we're only going to draw a static quad and just leave it there the whole time. So this should be sufficient. And then there is not going to be any so we're not going to have like a texture or anything. So I think we just need those two variables, vertex array object, vertex buffer object. So now let's have another function called let us call it I don't know, init. I don't really want to call it init renderer because we're not doing anything that complicated, but we will just do that anyways. So the first thing to do is to I don't know if we need to do this. So maybe we will do that later. I don't really need those. Oops. So first thing we need to do is we need to GL gen a vertex array. And we are only needing one of those. And it is GL context dot vertex array object. And we're just gonna immediately bind it because it's the only one we're gonna use this whole program. So we will just bind it immediately. And just leave it bound because there's no reason not to. And then we need to do a GL gen buffers. We will do one of those, and it will be this again, except it's going to be vertex buffer object. And then don't need to do anything else there. We're not generating a texture. Don't think we even need to do anything like enabling blending or any of that. But what I do want to do is define the vertices. So we'll do F32 vertices. We just need 4, so minus 1, 1, minus 1, minus 1. Make sure everything here is lined up. 1 and 1, and then minus 1 and minus, 1 and minus 1. Minus 1. So those are the four corners of the OpenGL window. And that is all we need to draw something using the vertex or the frame buffer shader. So we need to bind so after we've generated this buffer, we need to bind it so that we can load it up with these vertices. And then we do like a GL buffer data, GL array buffer, size of vertices, address, GL static draw. So we are not going to be updating this ever, so it can just be a static draw. And then, oops, now that is loaded, we can do, let's do that. We can, we need to do like that one. We need to do enable vertex attribute array. So we're gonna basically we're setting the layout for the shader. So I haven't started writing the shader yet, but the first the layout, the first input is just gonna be the set of vertices. I don't actually even know if we need to do this. So the stride is 4. We don't care about this. There's no stride, so the stride is just 0. Oh, yeah, like so there's just 4 of them. 4 of them? No, there's just 2. Sorry, there's just 2. And the stride is like, I don't think this matters, but size of F32. Yeah. That is that. Do we need to do anything else? So yeah, we don't have to do anything else with that. So we can just leave the buffer bound and we can, yeah, I mean, it's not really any reason to unbind it right now. So that is okay. Now for the shader, how do I want to do this? think the fastest way of just doing this, what time is it actually? Let's see, where are we at here? I have been streaming for an hour and 26 minutes. So maybe that's okay for a little bit more, but I won't go too much longer, I don't think. I'm pretty getting tired. Yeah, so the quickest way to just do this right now is basically we just want to load the shader and get the shader to do something. So I don't even think we need this clear color once we're done the shader, but that is fine. So let us add I32 program, let's call it PID, not to the color, this PID. And we will have to start by doing yeah, let's do it here. So GL context PID is equal to program from files. And we will just directly put them here. So we'll call vertex vert.glsl and frag.glsl. And we will have to define this function. This function returns an int, static. Did everything here yet? Yeah. So it's a static int. It's a program from files. Char pointer vert char pointer frag. And then yeah, it's fine for now. And then we're gonna have a so I'm gonna add my string type now because I want to use my string slices. So usually what I like to do for strings is I hate using null terminated strings because they are a disaster. So what I usually do is I do a well, also we need a size, so we're gonna have to include standard def.h. Yeah. And then we're gonna make a size here. So I usually use a signed size rather than an unsigned size because it's very often you take the difference between lengths. So you don't want it to overflow to the maximum value. Now you don't know, like, so if it just overflows somewhere like past or like somewhere slightly less than the maximum value, you don't know you can't really like know clearly that overflow occurred because maybe you just subtracted, like maybe one of your strings was like some giant length and the other one you just subtracted a little bit from it. You can't tell, so that is why it is preferable to use signed types. And I like the pointer div key because it's enough to hold the difference between pointers. Out of drink, so that's fine for now. But yeah, so it's just large enough to store the difference of two pointers, which makes it like really useful for sizing because you can use sometimes you go to like the end of a string and then you have the end and you want to subtract the start to get the length. So that's a pointer difference. So you probably want to use something like pointer diff t for that. So we have size, length, and then U8 pointer data. So again, I don't use like signed characters, which is the standard. I don't even know if it's standard, but it's how it normally is. I just use unsigned characters because that is sufficient. It's more clear. Like you could also think of this as U8, as in UTF-8. So we need to give this a name. So oops, S8. Won't define the macro for that yet, because I don't need to do that right now. Now we will have read whole file, which is going to take up file name, and it is going to try to read them. So S8 ret equals 0. I32 file descriptor equals open file yeah, path, and then open read only. And then if fd less than 0, return ret. Otherwise, we're going to need to include some things here. So first of all, we need to include F and FC, it's called fcntl.h, and for read, we need unistandard.h. Let's just copy this. And then for lseek to determine the size, we just need unistandard.h. So that is that. So now we can do is lseek let me just look at my sorry, wrong. That's why. It's, okay, well, I can just look up what the variables here. So we want to do lseek fd offset 0 seek end, and then that is going to be stored as the length. So ret dot len equals seek end, and then need to else seek back to the start. So fd 0 seek beginning. I'm sorry, seek set. Yeah, right. Seek set. Believe this is just right. Yeah, so everything there looks good. Besides, I should just make sure these are long. Then we need to do an if. We need to do, sorry, we need to do, fine, let's do it here, it's fine. Ret.data equals malloc. We'll just do malloc for now. Just because, and then if really it's probably better to just crash in this case, but that's fine. If ret.data equals null, ret.len equals 0, return ret. And then we will do a little bit of a read. So read ret.fd fd if ret.len does not equal read fd ret.data ret.len. Well, this case, it's a little bit annoying. So if we don't read the whole thing, then what? I don't know. Ret.len equals 0 for now, and free ret.data. If we get that, then that's a problem. Otherwise, we just return ret. Or in both cases, we just return ret. So good. So now what we want to do is do a S8 vert fine. SAV equals read whole file vert, and S8F is read whole file fragment, and S. Okay, that is good. And then I32 PID is equal to I think it's like GL create program. GL create so yeah, GL create program. And then probably before we do that, we should do if b.len equals 0 or f.len equals 0, return -1. And then I'm gonna have to do the compile shader stuff, which is a little annoying to do right now. So we need to do is do BID equals, I'll write a little helper function here, compile shader. We'll take a, it's going to take some types. It's going to take the shader type. So vertex shader first, and vert d will take the string. And then FID will equal this, except this will be fragment. And then we'll have to write this function as well. So compile shader U32 type S8S I'm gonna just do some, well, actually, it's fine. So I'm not gonna handle the errors properly right now, but that's fine. So U32 shader ID is GL create shader of the type. Then we need to do a shader source. This is a bit annoying. So shader source, we need one of that for that shader ID. Then we have to pair double star and address of s.data, but wants it to be a character star for some reason. And for some reason, the size needs to be passed in as a pointer to an int. Who knows? So again, s.len. You could also use like null if it was null terminated, but my strings are not null terminated, so we will not be using that. Shader SID. So we're going to compile that, and then if res does not equal GL true, we are going to return -1. And we should also, well, yeah, well, we will be good and delete the shader, but otherwise we will return shader ID. Okay, so now we have all that done. Next, we just need to link the program. First, we gotta like attach these to the program and then link the program. So first, we do this VID, VID, FID, GL link program, PID, GL validate program, PID, and GL use program. We're only having one program, so I'll put that here. And then we can delete the shaders from the GPU because we're done with them. And then we can free v.data and f.data. And we can return the PID. So that we should have a program. Sure. Well, good. So I need to include standard lib first of all for malloc and free. Now these are not defined in the GL header for some reason, but they are defined in the GLES header, so I will just include that, even though it's probably not correct. I didn't type def the string type correctly. That is typical. Main 66. Yeah, that didn't add that. Semicolon. Right. I think I need to do. I think you need to pass like a variable. Oh, right. No, you need to make your own variable for this. So to to check if the shader compiled successfully, we have to do a this there. So that would be that. Gen vertex arrays. Yes, that is what I meant. this has some stupid const on it for some annoying reason, just to annoy everyone, basically. I don't use const because it's annoying and it never actually solves any. It has never ever solved me. It has never ever stopped me from making a bug, so it is useless. But we will just cast that away. Now we have to call init renderer, which we will do where. Probably here after we've spawned the window. Just call that. So still getting our window, and we've got all the boilerplate stuff set up. So we're drawing at vertex. Now I've been streaming for quite long enough, I think. Well, okay. Let us just write a quick, very basic, quick shader, vertex shader and fragment shader. Program from files. Right. We're not actually checking and we're clearing this every time. So that will be what we need to do. So let us just quickly draw the most basic of shaders. I can remove raylib.h. Let us open libraylib jar and main.o. Don't need that one anymore. Oops. Okay, so now we will open vertex.glsl and we will do version 460. So I do here. Layout 1 in vec4 position. Oops. It doesn't matter that we only passed 2 vectors. It knows that we only passed 2, so it will do the correct thing. Based on this vertex attrib pointer. So void main. And what we need to do is set the GL position variable to position. And that is all we need to do. In that one, GLSL. And then for the fragment shader, it should be 460 core. So 460 core void main. This one is going to take in nothing. It's going to take this, and then it is going to right. So we need to know what the pixel is. For now, I'm not going to do that. I'm not going to bother with that. I will just set the color to red, light. Don't I use red? Whatever. I'll just set it to red. So what we will do, I mean, the light blue, 0.2, like a very light blue, and 1. So that should be all we need for those shaders. Now one thing I want to do next time is add hot shader reloading, because we're going to need to do that. But I didn't really need to reload. Oh, good. probably got trapped by one of my traps, so let us see what's happening here. Let's go O0, G3, just quickly check. Okay, BB, run. We're crashing in the driver, so that's not very helpful. That is gonna have to be left for next time. I don't want to debug that right now. Probably I just did something wrong in this last little bit where I was trying to set up this shader compilation. Well, we didn't check here if these were... Yeah, we didn't check here if FID equals -1 or VID equals -1. I kind of need to do some more work, but for now we'll just do that. If VID equals -1, return -1. Again, I should do this, but GGL context.get. So it's not that, it's something else. But I will leave that for the next stream. I'm sure it's just something stupid that I am doing in the setting of the shader. Or am I like swapping buffers too often? I don't think so. I can just set the, well, I don't want to do that right now. So, yeah, so for now, I think we will have to stop. But, looks correct. Why would... just before we free this, I just want to dump these. F right. I need standard IO for this. F right. V dot data 1 V dot yeah V dot len standard out and F dot data F dot. That looks correct. Those have both loaded in correctly. Nothing wrong there. I think you can actually read the position from the fragment shader, but we'll do that later. Yeah, so everything there is correct. Why is that crashing in the driver? Yeah, I don't know. I'm too tired to look at this right now. We will have to look at that a different day. So, um, let's see if there's anyone I can raid. Otherwise, yeah, I'm not seeing anyone off the top of my head here. So, I think I will just call her for now. So, I guess you guys don't need to see chat in two different places, but that's fine. And I totally messed that window up. That's okay. Um, yeah, cool. So thank you all for watching. Be sure to stream again. Just about done all the boilerplate GL setup. Drawing a window, blah blah blah. Getting a fragment shader. And once we've got the fragment shader, we'll be able to start. Where's this Mandelbrot that I had open? Not seeing it anywhere. There it is. So, yeah. So now that we've got that, once we've got all this shader working properly, we will start writing the fragment shader to actually draw this at a really high speed, hopefully in real time. So, yep, cool. Thanks for watching. See you guys later.